We invite here Head of Department of Strategic Project Autodesk Юлия Шмакотиной. Good morning, ladies and gentlemen. We set up the international community of Autodesk users. Many of you are members of the community, and those who are not, at least once asked your questions in the forum. Those who give the answer are members of the community, and it's important for us that you talk the same language. We're happy to ensure interaction, but it's important for all of us to establish interaction between you within this ecosystem. More than 2,000 answers which helped you to work were received from other users from that community. The Russian language community is one of the most efficient in the world. It operates in 8 countries, but the Russian language community is one of the most efficient. Then we set up the expert elite, as Anastasia said yesterday. Experience proved that their opinions are most valuable, people who can be trusted, people who are most active. Please wave your hands. So we have a lot of people. Come to their booth. Today one of them celebrates his birthday, Pavel Medvedev, a person who has the most popular Fusion Telegram channel. Pasha, happy birthday. 5 years ago, one more event took place. As you remember, 5, 6, 7 years ago, we started actively promoting BIM in Russia. And 5 years ago, we gathered the first BIM leader club of the people who are the advocates of BIM in their organization. They have to exchange ideas and find new ways of implementation of that technology in their organizations and in the market as a whole. Only operating together we can do it. The BIM Leader Club set up the first industrial BIM standard. They are very active in interaction with government agencies and market players, and since that we set up quite a number of clubs. In each industry we have an industrial club. The first club of the BIM leaders was a semi-closed organization. The remaining clubs are very open and we invite the participants. The main projects of the clubs at the initial 1, 2, 3 years of existence is setting up industrial standards for all the people operating in a certain industry, manufacturing, architecture and construction, media and entertainment, will speak the same language, implement projects in the same way, and the industries would develop in a more harmonized and successful way. Moreover, it so happens that innovations should be promoted not only in the market but inside our companies as well, especially if it's a large company, if it's a large government-owned corporation. Exchange of opinion within the club makes the people drivers of innovations inside the company. It helps them to grow professionally, and we would be happy to see you in those clubs. Talking about communities and development, we think about what is going to happen not only today but in the next few years. We're talking about students, young specialists, and we focus on them as well. Autodesk is the global sponsor of the World Skills. We took part in more than 30 competences out of the 50. Future skills with new BIM competence involved. This is a video from the World Skills Championship this year in the city of Kazan. It was a large-scale event, and my colleagues will tell you more about it. Our national team will tell you what they did. This is one of the areas where we would like to operate. We, together with you, would like to continue cooperating in each and every area. I wish you every success this day. Thank you for attention. Good luck. We invite Vice President Autodesk EMEA Walter Dopplmair.
Доброе утро. Just by show of hands, who has been here yesterday to watch the main stage? All right, so quite many. So, yesterday you had Jack Doxey talk about the powerful impact your work has on this world and why we believe in the opportunity of better. Today, I will show you what Autodesk is doing to help architects, engineers, and contractors to leverage automation to get the best of all the opportunities this change generates. So what we will do today is specifically look into the thing of automation. And what we've heard yesterday is that the world population is growing at a very fast pace. Globally, we need to build the unbelievable number of 13,000 buildings each and every single day of the year just to meet this demand. 13,000 buildings. And we need to build enough rails and road to wrap the world 30 times every year, 30 times around the world every year. And as you can see, the numbers are also very large for Europe. It's not just, in emerging countries, it's really Europe also where we see huge numbers. And by the way, a large part of this will be done in emerging economies. So not only will we need to build new bridges, roads, railroads, and buildings, we also need to maintain and protect our existing built infrastructure. And then there is an interesting number. About $4 trillion worth of assets are at risk currently just because of the climate change. That's an unbelievable number. And the UN predicts that by 2050, about 5 billion people on this planet, that's approximately half of the population on this world by then, could suffer from water shortage. So we know that our built environment has a negative impact on our planet. 40% of all the energy we consume on this planet is used by buildings. And buildings use about 25% of our water. And the building construction is responsible for 30%, so almost 1/3 of all global waste, just coming from construction. So massive numbers, which show that we need to do something here. An example from here, in Moscow, an average of about 50 million cubic meters of construction waste is produced every year. 50 million cubic meters. And this number is predicted to go up over the next few years as we see the broad-scale launch of the renovating housing project here. So that will create even more waste. So all of this, of course, creates a huge challenge for the world and a big opportunity on the other side for the AEC industry. We need to do better. And we need to adopt new tools and technologies that not just enable us to build better houses and bridges, but really to build a better world for all of us. And this is exactly where automation comes into play. Today, we are going to show you how Autodesk brings more automation to the design and construction process, and we'll start with design. And another local example, so Moscow-based design bureau Rusprojekt, we're looking to develop a scalable solution to tackle this waste problem, this construction waste problem. A solution which would enable waste disposal factories to sort of produce products which are really useful out of the waste. With the design mainly carried out in Revit and in Civil 3D, our BIM 360 solution enabled Rusprojekt to bring together over 100 experts from remote. So people not in the same place, just were brought together. They also produced more demonstration, and they were able to deliver a scalable, unique project in the shortest possible time. And the first such waste disposal factories with this new approach will already open next summer, first here in Moscow and then throughout the country. So a very good example. But automation can also help you embrace productivity, improve productivity, and reduce the amount of time you spend on repeatable tasks. That's actually the purpose of automation. And one good example of this is enabled by our partnership with Unity. So who knows Unity, by the way? Yeah? Oh, quite many too. So many of you obviously have used Unity in the past to create immersive experiences. For a typical project, it required a lot of coding, very specific expertise, and a lot of time for mapping all the materials and the textures. But now with the new solution, with a simple click on a button in Revit, tens of hours become seconds. And you can very easily experience virtual reality, change textures, and also explore your designs in a very rich 3D environment. Just removing, guesswork from what a 2D design might look like. Our next example of automation is Dynamo. A few years ago, Autodesk released Dynamo for Revit. And this is sort of a visual programming tool which allows users to program without even knowing how to code. So may I ask you again, who is using Dynamo for Revit? Any? Oh, also quite many here. Right, so what's new is in May, we released Dynamo for Civil 3D. Engineers can now use this to sort of develop scripts and share them to automate tasks like generating complex geometry or objects like signage, or using elements from other engineering disciplines in order to populate models with rich and accurate data. Such workflows, of course, save a lot of time, and the most important thing, they're applicable for all disciplines of civil engineering. The next thing we're working on, and that's something we've started some time ago, is giving customers in AEC the ability to use generative design for design exploration. We are basically working on eliminating the need for coding by combining Dynamo with an optimization engine, which then allows you to explore dozens, hundreds of design proposals, design options, from which you then can choose the best one. So what you see on the screen is exactly the process I described, with the optimization of a tile pattern in our public beta called Project Refinery. Refinery is actually integrated into the Revit environment, just like Dynamo. And of course, this is only our first step to make generative design more accessible for the people, so more of you can use it. Let's now look into a new trend we are currently seeing on the market. There is a convergence between BIM, the Internet of Things, and artificial intelligence, which will create new opportunities for a completely new level of automation. And this will be even more transformative than what I've described so far. Let me explain that. Every year, Gartner publishes their top technology trends, which you can see here on the screen. This year, you'll find 2 new trends. Actually, they're not exactly new, but they made it to the top 10 list now. And this is digital twins and smart spaces. They are now listed in the top 10 technology trends. And this is very interesting for AEC, as when we combine these 2 new trends, this brings together IoT and BIM in a way that is really useful for owners and users. Let me show you. I mean, everybody knows that IoT is creating an explosion of data. Owners and operators can now make use of this data to better understand how their spaces are being used by their occupants, so that they can optimize their assets and better serve their customers. So what that means is they can make their spaces smarter. And smart spaces is actually currently one of the fastest growing markets we have. Fast growing, large, and very promising in terms of technology, but also in terms of services. What you can see here is that whole thing in action. This is a video from AU Las Vegas. Computer visioning made it possible to dynamically track the movement of the attendees. And by doing this, we can see exactly how people behave during the conference and how they respond to activities. And next, in the next step, as you can see here, a digital twin of the attendees was created. Very simple, but we exactly track the movements here. And once you have that digital twin, you can present that information in a BIM model of your space. In this example, it's a bridge. Now you can see in real time the physical world with a real bridge, real people, and its associated digital twin. So you can really track what's going on in your buildings, in your spaces, in your environment. And then, if you finally add IoT sensors to this scene, which here are acceleration sensors on the bridge, then you can also understand the physics of the space. And this is what we call smart. So why is this important? With a smart space, designers and operators can see how people move inside and interact with a building based on different times, temperatures, and other factors. They can compare as designed and as built models. So they can compare what they intended to do and what reality looks like in the end. This insight allows owners to optimize their spaces in the short term, so that's optimizing existing spaces, but it also allows designers to use this wealth of data for future designs, just to make it better in the future. Now, another example of a smart space, if you go bigger, is a smart city. To improve a city, I think it's clear that you need real-time data. You need to see how things are moving in the city. We are investing in this space through our partnership with Esri. So Esri partnership brings now together BIM and GIS data. Since we've announced our partnership with Esri, we've already released the ArcGIS connector integration that's already available, which helps design teams to stay connected in real time and use GIS in a BIM workflow. I think that's the huge benefit we have now, really use rich GIS data in the BIM workflows. With this data in a combined view, you can predict and prioritize where a city needs to adapt in the case of external factors, like flooding, population growth, earthquakes, so everything which impacts sort of the city can be simulated. I know that the Smart City project in Russia is quite promising, so we've seen quite some success here with, I think, already 52 Russian cities taking part in this project. What's clear is that people-centric design and advanced digital engineering solutions will help us to improve the competitiveness and sustainability of these cities. And in the end, it's about creating an effective urban management system. Finally, to create a safe and sustainable environment for our citizens. This is what smart cities are all about. But whether it's a city, a bridge, or a building, it's important that when BIM combined with IoT and artificial intelligence is going to redefine how owners can optimize their spaces and how designers, on the other hand, can use this wealth of information to improve the future designs. That's the whole story. And it's now my great pleasure to welcome Tatiana on stage with two of our customers, one from Barcelona and one from Moscow, to talk about how our customers change the future of construction. Welcome, Tatiana, and your guests.
We have been hearing for 2 days that the world is changing. And to stay competitive, we have to take risks, and to change with the world, we need to accept new technologies, change the way we address new tasks. Together with me, I have two co-founders of two young companies, startups. They decided to take the challenge, Stuart Marks and Bogdan Murakov. Stuart, would you please tell us how you use robots at construction sites?
4 weeks ago, on a construction site in Oslo, a steel beam was brought to the attention of site management. It was 3 centimeters deviated from where it should have been, and it had been missed by all the existing site quality assurance processes, including the on-site surveyor. If left undiscovered, this steel beam would have cost thousands of euros in extra costs, at least 7 days of delays on site, and the valuable time of at least 8 site managers. And the really crazy thing is that this is considered normal in construction. This is the cost of doing business. But what is not normal is that this is automatically flagged out by an advanced AI software platform developed by Scale Robotics. It meant that within 24 hours of this issue actually going wrong, site management had this information in their hands so they could fix it at no extra cost the next day. But before we kind of get into all of that, let's take a couple of steps back and let's ask the question of why did this even happen in the first place? And at Scale Robotics, we really believe that at the root of this problem is the fact that we're designing digitally, but we're still constructing manually. So no matter how good your plan and your schedule is that you've done on Revit or on Navisworks or whatever software you're using, everything's to the fraction of the millimeter. Ultimately, there's a person in the field with a tape measure and a bit of string that's basically putting things wherever they feel like that day. And it's this risk and uncertainty that we have in construction that essentially leads to things like this steel beam slipping through the cracks. At Scale Robotics, we believe that the solution is to bridge the gap between the digital world and the physical world through a combination of robots and AI software platform to automate progress monitoring, to reduce risk, increase quality, and keep projects running smoothly and on schedule. Our autonomous mobile robot is 10 times faster than existing data capture platforms, and it navigates around the construction site by itself. Here we have the robot, well, one of our robots, in the Netherlands. So this is driving around a construction site in Utrecht. You can see it's driving around. This guy does not care about this robot at all. He's after 2 days of it driving around, he's completely bored, and it's just become another tool on the construction site. And as you can see that the robot isn't stopping and scanning and stopping and scanning like a traditional laser scanner. It's actually using a technology called SLAM, which means that it can continuously move, and this is what you're seeing is what the robot sees. So this is all the sensor data. So everything that the robot sees, it's dynamically adding to the map so that it can continuously move and capture data so much faster than existing technologies, which means we can get that information into the hands of people so much faster. So we take all that information, we upload it automatically to the cloud where our software platform is, and then we compare it to the BIM model. And then the first thing that we do is we just color code everything in the model. So everything that is green is within tolerance, everything gray we don't have enough information, red is missing, and orange means it's out of tolerance. And the idea is that we're trying to make this as simple and as easy as possible, to take something as incredibly complex as construction and just make it so easy that anyone can understand what is the state of their construction site. But the end result in construction is normally like this. It's kind of like shining a black light on your construction site. Suddenly you can see all the nasty details, all the things that have gone wrong. And on this site, they wanted their building to be plus or minus 4 millimeters. So, of course, it's completely orange. So this is shocking, a little bit overwhelming, and it's also completely useless. I don't need to know that my entire building is out of tolerance. What I need to know is what is putting my project at risk right now. What are the things that I should dedicate my time to as a site manager to make sure that my project continues smoothly? So we've put a huge amount of energy into making sure that all this information is searchable. It means that you can immediately get to the information you need at that moment. So here we've brought up a number of filters. Now we're selecting just the steelwork because potentially that's just what I care about today. You can filter by any element that you have within your model. You can then go through a number of other filters, so you can also go through date, which means that I can just maybe search for the information that was taken within the last few days, so I'm always looking at the most accurate information. And then, most interestingly, everything is ranked by the magnitude of that deviation. So here I can just say, okay, show me all of the mistakes on my building, which are between 11 millimeters and the maximum range. And then everything within that list is actually ranked by the magnitude or the potential risk of that element. So then I can click to the top of the list, I can click on the element, I can visualize the deviation using a heat map. So within 5 seconds, I've diagnosed what is the problem with this beam, what do I need to do with it? And then I'm only human, so I want to see it with my own eyes. I click, I can get a 360-degree image of that beam. Every single element within the model is automatically tagged with a 360-degree image. So all that information that was generally lost in the back of a drawer on a hard drive is now there, ready for you to use when you actually need it. And then every element is also then, as you might have seen, highlighted with where it is within the image. But what you're seeing here is you've basically just seen a snapshot in time of how you can diagnose your building for that day. But we're capturing this information daily, weekly, monthly, so we can capture the progress of the building. So then we're giving you percentage completes, so we're automating that process, but we're also extracting trends about how your building is actually operating. How is your construction site actually working? So is there a problem in one part of the building? What are the schedules or what are the schedules that are putting the project most at risk? Where are the areas where you're most likely to be behind schedule? And then bringing that to the attention of site management, instead of being reactive, you start to become proactive on your project so you can keep it running smoothly and reduce the risk on that project. I think I've just kind of scratched the surface of what we're doing at Scale Robotics, but this really can't happen in a vacuum, so I really have to say thank you to everyone that's helped, including the guys at Autodesk who have done an amazing job at supporting us. And thank you very much.
Стюарт, у меня все же вопрос к вам.
Stuart, I have one question. Yesterday we talked a lot about a Forge platform. I see something similar in your solution. Have you been using Forge platform in your operations?
So the entire front-end interface is built on top of Forge. We chose to use it because it was so incredibly easy to just get things started. We're obviously a startup, so resources are a little bit thin. So we managed to get the front-end interface, I think, working and deployed on a real client site within, I think it was 2 months or so. And then the next step of what we're going to be doing with Forge is we're going to be integrating it with BIM 360 by the end of the year. So everything that you've seen here, all those issues that you can tag within our software platform, will then go across to BIM 360 so that you can share it with the team at large. So Forge has been a huge part of our development so far.
Отлично, большое спасибо.
Excellent. Thank you so much. Now let us hear from our Russian colleagues. Bogdan, please tell us about your business and what drove you towards use of artificial intelligence at a construction site. Thank you for your question. Thank you. Good morning. At Sarex, well, we've been incorporated in 2017. We are a resident at Skolkovo. We work in residential housing construction, in telecom industry, and in mining. In our business, we have seen 3 important requirements that came from customers. One, they want to use any device, any place, and that includes customer servers. We have to offer our service during the entire life cycle, and we have to provide good analytics, not just nice pictures. To provide the analytics, we use AI. We believe that AI development is the core of our business. This is what our customers are looking for. Today, we have more than 10 developers, and they are quite knowledgeable in AI. Very interesting indeed. Can you show us something real, something tangible? Yes, the first use case, the use of computer vision to evaluate the level of activity at a construction site. Here's what we did. A construction process is fairly standardized. There's a lot of equipment, there's a lot of resources. Our logic is simple. We use computer vision to identify various objects. We use data that we collect by using drones and by using stationary cameras. With this data, we look at what happens at a construction site. We look at various deviations from schedules, and we identify potential risks. What are your plans? Where do you want to take your platform to? Well, one more thing before I forget. The next use case, automation of monitoring and control. We check BIM model against laser scan data. At the input, we use laser scans from a construction site, and this data is updated continuously, and we compare all this to BIM model. This module, this solution, has been tested at one construction site. This is the venue of an oil and gas company. As a result, they have reduced their cost by 5 times, and they have created a unified digital environment for the entire construction project. We believe that the quality of data that we obtain from a construction site is improving, and the cost is coming down. We have been looking at this trend for a number of years. It doesn't matter how you collect data from a construction site, whether it's a stationary laser scanner or some sort of a mobile platform, a drone, or something. What matters is how we use this information. So we focus on the software. We match laser scans to BIM, and this is not something new, but the devil is in the detail. It's not easy to identify presence or lack of certain items. If you look at a wall, in the process of construction, it goes through several phases. We use computer vision to identify what is happening with each object. We use various technologies like self-driving cars technologies use LiDARs for detection and identification of objects. That is available to us. We have to identify various objects, understand what they are. There are many different types of objects and machinery in a construction site, and we have to work with all that. Where are you taking your business next? Well, we look at what our customers are looking for, what they need. The industry is looking for latest and greatest technologies. When our solution is implemented, it increases the speed of construction. A developer can start selling apartments sooner, and that translates into serious savings. If it's an industrial site, a new factory can be built and commissioned sooner. This improves the economic performance of a project. So we have 2 important tasks. We collect information from different information flows, and we build analytical tools to properly analyze data. We walk from the monitoring phase to analytical phase. We collect as much data as we can get a hold of. The more we have, the better algorithms we can build and the better efficiency we can offer to customers. So what we're saying is that robots, computer vision, AI, machine learning are here, and construction sites are no exception. I encourage you to keep an eye on the latest technologies, take risks, try them, test them, deploy them in your companies, be pioneers, be successful. I think we do not have time for questions and answers. If you want to talk to presenters, you can do that offline. They are all going to be here. We also have a special negotiation room at 12:30 in Africa area. You will get an opportunity to talk to the presenters. Thank you so much.
Thank you, Tanya. Actually, it's really impressive to see what our customers are doing with our software and how they really change the future of construction. We can bring new levels of automation to the construction site through machine learning. And we have seen brilliant examples. So what I'm doing next is really look into a few more examples how we can sort of help you automate the construction site. One new technology I'm going to talk about is Construction IQ. Actually, we've announced a preview release of this new technology earlier this year. Construction IQ is actually a machine learning-based capability that delivers risk analysis of quality and safety data using BIM 360. That's what it does. So let's think of Construction IQ almost like a personal smart assistant. And many of you know that a typical construction project has thousands of open issues, hundreds of RFIs, change requests, and even numerous subcontractors who make the problem even worse, who make the whole thing even more complex. So Construction IQ can now look into this mountain of data and help you to make sense of it. It helps site leaders to identify high-risk issues, high-risk and quality problems. Health and safety managers understand leading indicators of potential hazards. And it even helps executives to recognize risk patterns and take the appropriate actions so that nothing happens right from the beginning. Another example, and you've seen a bit of that already yesterday in Jack Dox's presentation, is Royal BAM Group. They actually use Construction IQ, and they are seeing 20% fewer quality and safety issues. So a reduction of 20%. I think you know what that means. And what they also tell us is they now can spend 25% more time on site, on the construction site, to care about the high-risk items. And this level of automation is helping BAM to take action and be more productive. This is what the whole thing is about. This is what automation is about. We are looking, of course, to identify other ways to increase productivity. And here is where we invest in acquisitions. Many of you will know that Autodesk recently acquired 3 construction technologies: Assemble Systems, PlanGrid, and Building Connected. I will talk about them in the next few minutes. What these technologies share in common is the ability to digitize critical segments of your construction life cycle, of your construction workflow. Alone, these technologies can deliver greater productivity by automating a specific portion of the process. But when integrated and used with our solutions, they help to streamline and automate the entire end-to-end process in construction, leading to more successful project delivery. So it's really about not just optimizing one specific segment of this workflow, but optimizing and automating the whole end-to-end process. Now, Assemble allows construction professionals to query and connect BIM data to key workflows. It helps to reorganize and enrich the design model so that it can turn into a real construction model. And this results in automation of quantity surveying, estimation, bid management, and also scheduling. The latest integration between this Assemble Insight and BIM 360 gives the project team a holistic view in the process across a common data platform. And that's the secret, right? Really have one single source of truth. Now, with the PlanGrid acquisition, we are extending the value of the digital model from the design team and pre-construction to the job site, to the team really physically on the job site. What you can see in the video, which is about to play, is a new capability that allows you to automatically tap into 3D to better visualize the surrounding environment of the job site. So this is a new application. And PlanGrid is just, of course, the first step towards bringing design and construction closer together. So to close the gap between the two. Then finally, Building Connected has completely disrupted the procurement process and has also created a robust network of construction professionals. It helps to strengthen your ability to find qualified subcontractors. That's what's the purpose. And we, of course, are working to expand the presence of PlanGrid, Assemble, and Building Connected so you can successfully use all of these technologies to automate your processes. So that's something which will come over the next few quarters. We'll just look into that, how we can distribute this kind of technology over more geographies. Now, that's an example we've just seen on stage, and actually the example was much more impressive than what I can show you here, is really about Autodesk Forge. So automation, and that's what we've heard, is really about scalability. In order to scale, you need access to your data and you need to have it interoperable. And that's why we are building our Forge developer platform. Forge's open APIs can be combined with your existing software environment. That's the most important thing. So you just use what you already have. So to customize workflows for your specific needs, just to automate things in a very individualistic way. Here's another example I would like to talk about, and that's coming from a leading Russian residential construction developer, Brusnica. They believe that the future is in open API systems. They've recently developed their own solution based on Forge and integrated with BIM 360. Now, they have transformed the payment process with that application. And there is even more potential to do and automate in the future. For example, to read a document's QR code, or to visualize BIM data, BIM elements, or for example, to confirm acceptance and fulfillment work for the procurement guys, for the accountants. And we have tons of applications out there already. Today, almost 100 integrations with Forge already exist. These integrations make your data more actionable across the entire project lifecycle. It also grows the ecosystem of technology available to you. That's like in the former days, the ones of you who can remember AutoCAD would have been nothing without all the applications. Now the same goes for Forge, but at a much, much larger scale. Forge is the new API and the new way for automating tasks. When data is actionable, we can all work, of course, smarter and better. So before I go, I want to leave you with 3 things. Firstly, Autodesk is actively building, acquiring, and integrating tools that help you to accelerate automation and make you more productive. Second, don't forget about the convergence of BIM, artificial intelligence, and the Internet of Things. This is a real game changer for AEC. And it's going to connect how we make and how we build. And number 3 is about, let's think of a project you might have, you are currently working on, and how you might be able to automate at least a part of it. Right? We have all the solutions here. Please do not start with everything, Start with a specific area, specific part of the workflow. Could it be space planning with generative design, or using construction IQ for safety, of course, as soon as it's available, and also for quality issues? Think how you might embrace automation on your project. That's what I would like to ask you, and then make it happen. As we've seen today, with automation, you can realize the opportunity for better. Better design, better construction, and of course, that's the purpose, better productivity. And we at Autodesk are really here to help you with that kind of process. Spasiba.
A dream is a bird. It only flies high if there's wisdom, courage, and belief. Since its foundation 95 years ago, the Republic of Turkey has completed countless grand works. Constructing the world's largest airport in Istanbul was the biggest of these dreams. The airport land laid unexploited to the northwest of Istanbul. The terrain was rough and riddled, with pits due to the presence of old mines. It seemed almost impossible to turn this place into an airport, but the journey had already begun. There was only one goal, the final destination. In a brief amount of time, an initial investment of 7.5 million euros was made, and a global team was assembled in order to construct this giant structure. The number of people working on this project could populate a small city, and they all
И все они приложили огромные усилия для того, чтобы реализовать самый крупный проект в истории Турции. Его реализовали архитекторы, строители, менеджеры. Каждый из них сделал все, что возможно. Они работали днем и ночью. 1 миллион кубометров грунта переносился каждый день. И рабочие инженеры работали для того, чтобы с невероятной скоростью реализовать совершенно невероятный проект, переместив 750 миллионов кубических футов грунта, 8 Суэцких каналов по объему. Итак, 22,5 миллиарда евро с окупаемостью 5 лет. К 2025 году здесь будет работать 225 тысяч человек. Вклад аэропорта в ВВП Турции составит 4,9%.
Based on such data, days elapsed, and Turkey was overjoyed in 2015 upon the announcement that the construction of the massive airport was underway. The seemingly impossible project has started to emerge slowly. A dream had just flown down from the heavens and perched on Istanbul. Everyone worked even harder as their work grew to become more visible, with more ambition and determination in their hearts. A project of this size could take almost 10 years to complete, considering the global standards. Even the design process could take a few years. Everyone, including workers, architects, engineers, and operators, were putting in superhuman efforts in this project. This grand project was being designed as it was constructed. Despite the challenging terrain and virtually impossible time frame, one of the largest projects the world has ever witnessed was constructed with the efforts of hundreds of thousands of people. The final stages of the new airport were finished, and the magnificent project was completed in exactly 42 months. This is Turkey's new gate opening to the world. The Orient and the Occident will once again be bridged by our nation. Moreover, this unique structure will be the new home for Turkish Airlines, Turkey's global brand, and it will provide a mighty infrastructure for the operations of THY, Turkey's pride and honor. Having a capacity of 10,800 baggages, the world's most advanced baggage system will be able to sort all baggages of a huge airplane such as the A380 in merely 90 seconds. An airplane from anywhere in the world that is destined for Istanbul will not just land at an airport, but a small city that never sleeps. Turkey's ever-growing steps will grow even further thanks to this unique project. It's now time to be proud. The world's largest airport is now ours. May this monument of triumph, the signature of the Turkish nation's faith and hard work, as well as its tradition to make history and turn what's impossible into reality, be auspicious for Turkey and the entire world.
На сцену приглашается технический...
Invite here CTO Istanbul Airport Ismail Hakki Polat.
Well, hello Moscow, hello all friends of Autodesk. My name is Ismail Polat. I'm the Chief Planning Officer of Istanbul Airport, and I'm very happy to have the chance to participate in Autodesk University here in Moscow. But also I'm extremely terrified to be at this stage now in front of this great crowd. So be with me the next 20 minutes, and hopefully we'll get through this quick. You've seen most of the project on the video. I'll try to add little things here and there to explain the process that we had in the last 42 months, an amazing journey we had from the planning stage going into the operation. As you know, our airport started operations in April of this year in full operations. And if you happen to be through Istanbul this past summer, you may have seen our airport and tested it. I hope you guys enjoyed that experience. If not, just let me know. I'll try to fix it for your next trip to Istanbul. So let's start with that. Istanbul was our inspiration for our project. As Napoleon once said, if the world was one country, Istanbul would be its capital. That's quite true also for aviation. If you look at the location of Istanbul, in 3 hours time frame, you can reach 60 major capitals, 120 countries, and close to 300 destinations through Istanbul. That makes it quite unique for aviation. Here you can see with a small aircraft, what we call one-aisle aircraft, such as Airbus 320, you can reach quite a lot of areas from Istanbul. With a big aircraft, two-aisle ones, such as 777 or 787, we can reach almost everywhere in the world. And Turkish Airlines used that to their advantage. Last 10 years, with their help, the aviation sector grew rapidly at 2 digits constantly in Istanbul. And last year, we have surpassed, together with Atatürk and Sabiha Gökçen airports, 100 million passengers barrier. Hopefully, we're going to go further with that. If you happen to be in Atatürk airport in previous years, you probably witnessed that it was getting crowded and crowded. It was getting more delays. That is why an infrastructure, a new airport infrastructure was a must for Istanbul. And the government started that tender process in 2013. Four construction companies of Turkey, Cengiz, MAPA, Limak, and Kalyon, won this tender. It was a BOT tender, so we had to invest, design, build, and operate this airport for 25 years. And for that operation, we are to pay a concession fee to the government. At the end of the 25 years, we are to give back all this asset back to the government. So we won the tender for 25 years, and with a concession fee of, including the VAT, 25 billion euro. That means every year we're going to pay back government about 1 billion euro. On top of it, we committed to invest another 10 billion euro for the entire airport infrastructure. So that's roughly 35 billion euro that will be given back to the Turkish people and the government. And the most challenging is that the first phase had to be finished in 42 months, 3.5 years. So in May 2015, we have started the construction. In October 2018, last year, we started operations. In April 7, Atatürk Airport closed. Now Istanbul Airport is in full operation. Obviously, we had quite a lot of challenges, but I think we can wrap up these in 3 major areas. One is the delivery challenge. We had to deliver this huge infrastructure in 42 months into operation. The issue of scale, I'll try to explain that to you. Hopefully you'll agree with me, the size of it. And between all of these, we were trying to put the soul of Istanbul, the hospitality of Turkish people, into our project. I said it's a quite large project. Our site was close to 80 million square meter, making us one of the largest airports in the world. 13 kilometers east to west, 9 kilometers north to south. Obviously, this project has to be built in phases. The current phase that is operational right now, about 10 million square meter of airside, complex airside with 2 parallel runways, 1.4 million square meter of terminal building, and another million square meter of other supportive buildings, 624,000 square meter of car park, making it the largest car park also in Europe, right now, which are all operational. But the work is still ongoing. We are building the 3rd runway. Hopefully it will open next year. We're not stopping there. Then we're going to build the 4th runway. It will follow with the 5th runway and another terminal building. Finally, we will stop at the 6th runway, 5th parallel runway, and a satellite building, giving us the capacity of 150 million passengers per year, but an infrastructure can be expanded to 200 million passengers per year, making it the largest airport in the world. I said large, yes, the numbers were large. Here are a few facts from the construction site. Please keep in mind about the logistics, delivery, installation, coordination, all of these efforts. 1.4, close to 1.4 million square meters was our terminal floor area, close to 5 times the Empire State Building. But since we are in Russia, it's roughly 3 times the Lakta Center, which will be the, as far as I know, the tallest building in Europe and Russia. 645,000 tons of steel. We could have built 80 Eiffel Towers. I don't know what we would do with them, but we could have. 6.7 million cubic meters of concrete, equal to 2 Hoover dams. And last night I learned that it's almost same as the Sayano-Shushneskaya Dam, which is, I think, the largest dam also in Russia. A terminal roof, 450,000 square meter, 18 Rome Coliseums we can fit in, or 2 Luzhniki stadiums we can fit in that terminal building. Earthworks, as you see in the video, reaching 1 billion cubic meters of work has been done in 1,000 days. So every number in construction was quite big in our project. To deliver that, we also had to have resources. We had more than 3,000 heavy machinery on site just for the earthworks. What you see are all the trucks that we used. It took about 6 hours to put all this truck like this, and the site was not happy because they lost a day, which was 1 million cubic meter. But the real heroes were the workers. Total of 120,000 workforce went through the project. At the peak on site, we were 33,000 people. So those are the real heroes making the project reality, and I'm very, very proud to be part of that team. Of course, this magnitude had a lot of problems. You saw those trucks, but when you put those trucks in a very small area on site, they look like ants. Just to be able to track them was a major challenge. So we have installed GPS stations, and we tracked every movement of every vehicle. We matched them with the planned map. If there was any deviation from their route, if there was any delay, or if any truck stopped for 15 minutes, we would send a team out there to investigate. You know, the driver may have been lost, or he may be sick, the vehicle may be broke down or had a flat tire. That way we were able to overcome all these obstacles and keep all the machinery working to be able to finish that 1 billion cubic meter of earthworks in 1,000 days. On the buildings, BIM was our guidance, main savior. We didn't start designing the project in BIM, but a lot of our designers using those tools, but we use it mainly for coordination and collaboration purposes. That small project became the largest digital model in the world. We have integrated all different disciplines, including the entire air site, into BIM model. What you see on the top videos are runways and taxiways, and now in a few seconds we're going to go under our taxiways, where you can see the drainage lines, fuel lines, AGL lines, aviation systems, and the layers of concrete and asphalt pavements also built into the model. The end result, through BIM, we were able to solve 600,000 clashes, where 240,000 of them were quite major, causing the potential to cause delays and cost. About 435,000 equipment with their attributes were put into the model, close to what we're trying to describe here with digital twins. 4 terabytes of information gathered through our model, and with an 18 gigabyte size, it is one of the largest models. I think as far as I know, it's the largest models in Autodesk servers. Obviously, next step, we're trying to use that for facility management. You're hearing digital twins and facility management, integrated use of these models. This is also our aim. It's just a necessity in order to operate this quite huge infrastructure. But the key, as Walter explained, and I've heard a lot yesterday, is to tailor your facility management and model to your operations. And this is what we're trying to do at Airport. We're trying to connect these systems into our airport operations. You already know IoT, BMS, SCADA, but we have other abbreviations in aviation. AODB, Airport Operational Database, RMS, Resource Management System, ASM, GCS, Advanced Surface Guidance Movement Control System. All these new things need to be incorporated into our model also. And this is where we are trying to make the best of our model. Here are a few pictures I would like to show to you. These are from the morning of April 7th. I don't think we will ever have a chance for these pictures. On April 6th, the entire fleet of Turkish Airlines took off from Atatürk Airport. After a 5-minute flight, they landed in Istanbul Airport, and they all parked. This is right before, 4 hours before the operation start, where all Turkish airline aircraft parked on our aprons. And this is our award-winning air traffic control tower, which an entire BIM model of everything, every system integrated has been created. So we pretty much have a digital twin of this tower also. It's a design by Pininfarina. They regularly design Ferraris, but we convinced them to design air traffic control towers this time, and the end result was actually quite successful, quite good. And about our terminal building, which is 1.4 million square meter, the collaboration and coordination was the key. And in all of that, we were trying to put the Turkish signature into our work, our history, our heritage into the design of this project also. We tried to put the light into the structure through our skylights as much as possible. We tried to put the Turkish patterns into these structures. And the end result gave us a quite large, light, and beautiful spaces for our passengers. And here's a new term we also started using here. We call it DBA, Design by Accident. If you see that at a certain time of the day, the skylights gave a crescent shape on the ceiling and on the floor of the terminal building, which is our Turkish flag. This was absolutely not intended, but everything came out together, but designed by accident, but the result was end up pretty good. The terminal building is big. We have quite long distances to walk. We call it healthy, because that's one of the diseases of this century. So you can have long distances to walk to stay healthy. Obviously, our architects try to put local amenities, local features to make your journey more pleasant. And we try to install 651 elevators, escalators, travelators to make your journey seamless and possible. On October 29th of last year, we have completed our project. On October 28th, we received our certification of Civil Aviation Authority. And on 29th, our president, Mr. Erdogan, inaugurated and opened the airport and named it Istanbul Airport. We didn't have any name before that date. And we didn't need any other name other than Istanbul. So this is truly a monument of aviation victory for us and hopefully for the next generations. Following that 6 months, we had trial operations with Turkish Airlines. About 500,000 passengers went through our terminal building. And finally, on April 5th and 6th, we had made the largest relocation from Atatürk Airport to our new airport. 12,000 equipment was relocated. And we still use BIM for coordination during this effort to relocate each piece of equipment on the new airport. The planned 45-hour move completed in 33 hours without any incident and accident, and the airport started full operations immediately. Since then, we have carried more than 30 million passengers. More than 20 million bags went through our facility. Close to 200,000 aircraft landed and took off from our airport. And daily right now, we are doing 1,300 flights, and that is increasing also continuously. And the next time if you fly to Istanbul, you'll be guided through one of these routes from our airspace and hopefully land safely at our airport. But the most importantly for us, for all the engineers worked on this project, was the big picture, which is this slide that makes us quite proud to be part of this project. At the end of the day, we're going to provide about 5% to Turkish economy, creating a value of more than $40 billion. 225,000 employment opportunities will be part of this project. And this is the part that really makes us proud to be part of this project. So before I leave the stage, for your next trip to Istanbul, We are all waiting for you. We'll be very happy to welcome you in Istanbul. And if you have visited Istanbul before airport, this short next video will tell you maybe how you can use it better. If you haven't, this is a chance to see what you will be expecting at our new airport. Again, thank you very much for all eager family. Thank you.
На сцену приглашается
I invite here Director Industrial Machinery Autodesk EMEA Karl Osti.
So what an amazing project, Istanbul Airport, really amazing. We heard earlier today and also yesterday that there's more transformation going on also in the AEC industries. Customers like Royal BAM and also AECOM are using manufacturing techniques in order to transform their industries for the opportunity to do better. For manufacturing companies, the need for doing better is being driven by a number of factors. The products we design are getting more complex. Electronic, sensors, new materials are being present in every machine and every product we design. Competition is increasing. Manufacturers need to have the ability to deliver improved functionality in an agile fashion. And on top of this, customers are more demanding and expecting products to meet their personalized needs. The great news for manufacturing companies facing this challenge is really that the means of production are showing great promise to help them to do more with less. Advanced manufacturing technologies, new methods of automation, automatic techniques are opening up an amazing new possibility space for manufacturers to increase productivity, to improve faster and offer the flexibility to implement design changes without having to implement new production processes. But these new technologies require a new way of working, new processes, and also new tools supporting them. Now, the problem is this. The tools we use today to do our jobs, to design and manufacture products, are disconnected from each other, use different file formats, have completely different user experiences, and requires users to translate, manually transfer, and often recreate data in different file formats. In short, it's a mess. The average design engineer wastes 1/3 of his time for non-value-added tasks. Tasks as dealing with incompatible file formats, describing notes, re-recording comments into the PLM systems. The opportunity for better for manufacturers is not just about building products better. It's about making processes better. It's about making work better, and it's about making life better. The need for better drives customers to look at the next generation of efficiency, introducing new workflows and new processes. Just imagine you waste time in a project like this, the largest telescope in the world, more than 1 million parts involved, and the obvious, you need to get it right the first time. Dynamic structures solve that problem using Autodesk software to design, manage, and install this amazing piece of technology. And the need for better is driving companies like Claudius Peters, as you heard yesterday, to do things differently. For example, exploring new design options, different workflows to improve product performance. But it's going far behind just the last lightweighting exercise for Claudius Peters. This is Thomas Nagel. the Chief Digitalization Officer at Claudius Peters. He has initiatives to put in place he calls Inspired Excellence. The company has 4 main goals in their digital transformation journey: to improve product quality, reduce lead times, reduce cost, and increase customer satisfaction. One of the key ways that Claudius Peters realizes these opportunities is through Autodesk collections. With the Product Design and Manufacturing collection, Claudius Peters has access to tools that help them to streamline, unite teams, improve collaboration, and automate processes and disciplines connecting their BIM models with detailed component designs similar to what we have heard earlier. Yeah. At the heart of the Product Design and Manufacturing collection is Inventor. This is Inventor 2020. It's the fastest, most capable Inventor we have ever delivered to the world. I recently saw a customer in Poland using an assembly of 2.7 million parts, 2.7 billion parts, and he used it with ease. Just a few years ago, it was completely impossible to deal with that without specialized resources. But it's not just about, improving performance. It's also about improving the experience, such as overhaul of the user interface, frame generators, and allowing you to do much more complicated parts. But it doesn't stop there. Like tolerance analysis, which we have added into the Product Design and Manufacturing collection, it's an example of how we are connecting manufacturing knowledge and data to design processes so that you can help make better decisions faster. In product design, the higher the tolerance precision is, the more expensive the part it is to make. With the tolerance analysis tool in the collection, engineers now have the ability to optimal balance manufacturing quality and costs before a single part is being cut. The collection is about making connections. It's about connecting design and manufacturing. And for many of you in this room who need to see your products actually in the context of buildings, it's also about connecting detailed mechanical designs with the BIM models. Here's an example that shows how Inventor and Revit come together to connect a detailed mechanical model for building components with the building information model. So you bring in Revit data, basically detailed all the manufacturing details in Inventor, and basically hand over the balcony model with the appropriate data to the BIM model for your customer. With these additions, Inventor 2020 is quite simply the best Inventor we ever shipped. Here's an example here from Russia. Alconit engineers and produces conveyor systems. More than 100 conveyor system and transport systems have been delivered to their customer called Uralkali. Uralkali is a major player and producer of fertilizer, and it's the customer, of course, of Alconit. Uralkali provides the environment for the planning process, like the structural information for their factories, and they're using Revit models. Alconit uses the plan to project their conveyor systems right the first time. The new level of cooperation was achieved thanks to Autodesk technology allowing this type of collaboration. The benefit? Reduced project execution risk for both organizations. With the collection, customers are getting all the goodness of Inventor, which is, of course, integrated with the best 2D design and documentation tool, called AutoCAD. So you update your AutoCAD model and Inventor model, which is connected to it, automatically updates. You change your Inventor model, and the AutoCAD model appropriately updates. And there's much, much more. There's technology such as Navisworks, reality capture, the visualization with 3D Studio Max, factory planning and layout tools, all of that a part of the collection. And of course, everything is basically put together also to manage your data with technologies like Vault and Fusion. Inventor is much more than a CAD system. Through the years, we have built a number of different workflows, directly connected Inventor with the CAM technology. We added simulation, and we recently also added nesting. Now take a look at this particular video from Matsutra. It shows a typical production process. However, you will realize this customer uses a 5-axis strategy for the workpiece holder in the middle. It's generatively designed and hybridly manufactured. So at this point in time, Matsutra was able to cut the preparation time of this workpiece holder and to produce this workpiece holder in days instead of weeks, without any additional cost. Here's another workflow I want to show you. The same technology Claudius Peters used for their clinker projects is being featured here. Fusion 360, which is a part of the collection, directly connecting with Inventor. And what you see here is, a wheelchair, and we basically drill down to a component of a wheelchair and trying to explore a complete new design using generative design in Fusion, which is integrated and interoperable with Inventor in that case. You now can come up with complete new design. It's not just a topology optimization. You come up with complete new suggestions. And what we do here is, in green we show these are the preserve areas, so please connect your design with that. The red ones are so-called obstacle areas, so please do not move into that spaces. And we use generative design with insights around material and production methods to come up with very innovative ideas. Now, we extended generative design over the last couple of years with new constraints and advanced capabilities. One capability is what we call unrestricted, which may allow you a combination of different production processes, such as multi-axis machining and additive manufacturing. But we also introduced complete new constraints in production methods, like die casting, 2-axis milling, and 2.5-axis milling. That gives us now the opportunity that you can compare results, the manually designed part with the parts coming from generative design. And the manual design part is a little heavy, and actually the 3-axis design is half of the weight. But the other thing you see on that particular slide is that the big difference is the time to manufacture that part. Okay? So now you're expanding your solution space to make proper decision. You end up in a multi-dimensional solution space. You see what the designs are costing. You see what the designs consume on time and what it means for utilization on your machines. And you get quite some interesting results to compare. And each result has a cost range and a median to it. And it's not just 6 results, it's hundreds. So it comes down to trade-offs. Armed with engineering information, but we realize that's not the only thing which counts. Now we enrich these results with even more data starting with cost. But these numbers for cost are not necessarily coming from us. This is a visualization, a scatter plot, comparing cost just like engineering properties. This empowers you to make the best decision for your business. Democratizing design with new constraints, enriching it with cost, help you to make practical and profitable decisions. And you want to manufacturing these parts, of course, efficiently. So we also continue developing Fusion's manufacturing extensions, which I want to show you here. This is the manufacturing extension in Fusion. It gives you the access immediately when you need it to extended manufacturing technologies, such as sheep and stello tool passes, hole and pattern recognition, in-process inspection, and also, of course, the additive and hybrid workflow supports end-to-end. It enables you to get technology to success in a very simplified way, per use, per month, or even on an annual basis. And that's all a part of the collection. In addition to interesting machining, in addition to integrating mechanical design, simulation and BIM, giving you access breakthrough technologies such as generative design, we added additive manufacturing technologies. We are now making it easier to connect the entire engineering team with the rest of the business. For better collaboration across the different departments, the new Vault 2 Fusion Lifecycle Connector makes it easy to manage your design data inside the organization, but also across the organization from a central location. And we don't stop there. We extend to value our data even further. We continue to build on the Forge developer platform. You saw examples on that earlier. Here's an example from a partner called Moicon. They are using Forge technology to reimagine how we design and manage factories. Moicon is transforming the factory floor by offering insights into operations, optimizing performance, and reducing downtime. Moicon is using Forge to create digital twins of factories and other facilities by connecting 3D models, process simulation, documentation, instruction data, and of course, maintenance cycle, factory management models. At Autodesk, our mission is really to make you and your customers' life better by connecting design and manufacturing. We're connecting data processes and break down silos. Silos between people, silos between machines, silos between machines and people. And it starts with putting data at the center of the process. Establish you a unified product definition that connects every one of the product development process at the early stage, connecting industrial design, mechanical design, electronics, simulation, and manufacturing. We unite different teams, the internal teams and the external teams, to improve productivity and accelerate innovation. Connecting design and manufacturing is really a key topic to enable the future of digital transformations. This is what we call the convergence of design and make. That's what we call the future of making. Thank you very much.
На сцену приглашаются технический эксперт Autodesk Артем Николаев и сборная России по компетенции
Artem Nikolaev, who represents World Skills competition team, Igor Kuzminich and Fyodor Timokhov. Good morning, ladies and gentlemen, friends. You are used to presentations on success stories. Presenters share their victories, their achievements. We are here to tell you about one history of failure. I'm standing in front of you. I am a technical expert in digital manufacturing at Autodesk. A few months ago, we participated in World Skills competition. This was a competition between teams of engineers in design, manufacturing, and assembly. of complex devices. You can see one example. This was the mission that we were given in the competition. We had to have the skills in these areas, and we had to have extra abilities associated with manufacturing. So every team member had to have 2 or 3 different skills. Let me explain what this competition is like and how we prepare for it. 1 year ahead of the competition, we get a competition assignment, and team members start development of a product. There are many iterations. A team has to make, let's say, a wheelchair, one phase after another, until we meet all specs. Then, when the team goes to the competition site, they would have to get components and tools along with them. And during the contest per se, they are going to have to put together this wheelchair. Well, this was the assignment this year. There can be other products that would have to be designed and built. This year, there were 8 countries participating in the competition, and there was not enough equipment for all. So we had to have a clear schedule for our performance. But the schedule may change, because if we plan to use a lathe and it's busy, if it's used by a different team, we are going to have to make changes to our plans. It is very important for organizers to give everybody equal conditions. So we have to show our ability to use different machinery. This is what they're testing. They are looking at the cost of a project. If it's cheaper, you get more scores. The less equipment and tools we use, the more scores we get. I'm going to pass it over to my colleagues, and they will tell you more about the competition, and they will explain why this is a history of one failure. I'm Fyodor Chimahov. I am from Krasnoyarsk. Let me tell you how I ended up on this team. I was in my 2nd year of studies in Aerospace University, and I was invited to join the team as an operator of a CNC machine tool. I was invited for the 2nd time to participate in a different team. I did not have a clear understanding of what I was going to do in this 2nd team. I learned to use a versatile lathe. Then I learned to operate a CNC milling tool. I am Yevgeny. I am from Bryansk. I graduated from Bryansk Technical University. Now I am in a master's program in that university. I was not a great student. I didn't care much about studies. I had a hobby. I spent a lot of time in my garage, and I was making all kinds of parts. The head of my department in the university called me up and invited me to join the competition team. I was an assembly person. I was doing a lot of welding. I am Igor Kuzminych. I was a student of Urals Radio Technical College. I always loved technology. When I was in the 2nd year, I was invited to join the WorldSkills team. I wanted to learn to write code, which was something that they only teach in the 4th year. And this gave me a great opportunity, so I joined the team. After graduation, I got a job at a nuclear power plant. I again joined World Skills team. I ended up in the final phase of the competition, and I met a lot of people there, and that's how I ended up on the team that you see on the stage today. This year we had to design a wheelchair. We had 6 months to do this, 6 months before the competition. We improved our skills operating various machine tools, and we learned to work as a team. We did not pay much attention to the exterior of this wheelchair. We looked at the functionality. This wheelchair can overcome obstacles up to 23 centimeters high. It can move 2 persons. The total mass of 2 persons is 210 kilograms. Maximum speed of the wheelchair is 10 kilometers per hour. It has a battery which has a quite long life. It can support 4 hours of continuous movement. The general cost of the project is 500 euro. This was the cheapest wheelchair that was presented in the competition. Over 6 months, we went through a full cycle of preparation. At first, we just had an office chair. We attached a motor to this office chair, and we tried to figure out how it moved. At first, we had a lot of issues with the drive chains. They would break, they would go off sprockets, and we tried to address those issues as they popped up. The vertical movement component was one big headache, and we were sitting there trying to overcome the obstacle, and we got support from the tutors who were available to us. They kept the project alive. They kept our concentration at all times. So this was quite a messy project, but it worked. In the final shape of this wheelchair, we used a lot of electric drives. We used microcontrollers to make movement of the wheelchair smooth. We used Autodesk Eagle software. It has a lot of component libraries and other useful features. In previous competitions, we had to bring a banner along with us that would have information about us. This year we had to make a video of assembly and disassembly of the wheelchair, and we had to provide description of all main components. We used Inventor. We did not have 7 million parts. We just had just above 100 parts, but that was very helpful to build a prototype. At the preparation time, we got involved in other international projects. We participated in the contest to build a bionic robotic hand. We tested our wheelchair, so how strong it was. We participated in another engineering competition, the robot battle, which helped us to get better as engineers. A few words about the impressions from the competition. This was a 3-day-long competition. The first 2 days were fairly good. Everything went as planned. We were slightly behind schedule. I lost 2 kilograms over the 2 days, but that was no big deal. The third day started well. I submitted the drawings and went to the tools room. I was 1 hour early, and suddenly I discovered that the electronic components were not ready yet. So I started building the luggage part of the wheelchair, and the electronic parts were still not available. Then I had to install a battery, connect all parts of the battery, and that was okay. I assembled everything, and then I came to Igor, and Igor said that the electronic parts were not working. So I went to help Evgeny to clean up the milling tool. We thought that we would be the champions. We thought we would be the winners. When I went to bed, I thought that I was going to be the winner. I called up my mom and I said that she should learn French because we're going to France. So on day 3, we were aiming at the top, and I couldn't see anything else. I was thinking that we were the champion team. We would get all the glory. When I came in, well, I forgot the brush to clean up the milling tool, and 15 minutes before the end, and I saw Igor doing some soldering work on the electronics. I thought that we failed. So I went back to clean up this milling tool, and this was the longest 15 minutes I can think of. Well, let me now explain what it was like. Day 3, the first 2 days were quite nice. Everything was just like scheduled. We needed to add the electronic blocks that were pre-manufactured. I started testing and realized that the wheelchair was not responding to any commands. Nothing worked. I fixed the problem quite quickly, within 1 hour, but there was one mechanism that was not working, the mechanism that lifted rear wheels, and that accounted for 20% of functionality. We could stop at that, but we decided to go further so that we could have a chance to win. This was the main mistake. 5 minutes before the deadline, when the time was running out, we could not do any work after the deadline. So I put the connector into a different socket, and that burned the microcontroller, and we could not submit a working wheelchair to the jury. The takeaways: we were too confident. We did not test the electronics on time. We were aiming at perfection. We could not stop when we could. What are the main conclusions that we're making from this? We should not try to make it perfect if we have a working model. If there is a deadline, we should just stop at a reasonable point if we can. The Chinese team won in this competition. They had a similar wheelchair. The Japanese team was the second. They had a very little tiny wheelchair, Kaizen in action. And there was a team from Taiwan, a simple, reliable wheelchair. It moved. Our wheelchair is not inferior to those that won in the competition, but we had tight luck. Well, in conclusion, I want to say this. We have provided our wheelchair for a test, and we were ahead of England and France, although their wheelchairs could move and ours couldn't. This is not much of a comfort. We showed good engineering skills, but that did not make us winners. We fulfilled the requirements. We met all the specs. We had an LCD monitor working, which is something that the French team couldn't. If we have a deadline, if we're running out of time, we should provide a working product and show it to an investor or to the jury to get more points. If we did so, I am sure that we would have one of the top places in this competition. I can tell the team members, if you see that your mates have a problem, don't just walk away. Try to make a collective decision. Maybe together you could do better. Maybe you could decide to stop fixing it until the very end. And don't call your mom and ask her to start taking French classes before it's over. This was embarrassing. You gave us some applause, and I again want to say something. There was a lot of drama there. Guys can participate in WorldSkills only once. So they started getting ready in February 2018. They were just recruits. They forgot about their personal lives, and they spent 18 months preparing for this. A lot of emotions, and you can imagine what it was like at the end. That's all. Thank you.
Уважаемые коллеги, оставайтесь.
Please be seated. It's not the end of it yet. You don't have to stand up. Please come back to your seats. We have one more thing that we want to share with you. It's important for us. You probably know that Autodesk has another strength. We work in a number of industries, and the synergy effect is great. Today, we have a very important event. We want to sign an MOU to build a center of competence in industrial design, something that is not very common in Russia. This is not absolutely new, but this is not something that you see all over the place. Let me invite the CEO of 2050 Lab, and Daria Topilsky, and the CEO of Autodesk Russia and CIS, Anastasia Morozova. They are going to sign the MOU, and then I will ask both CEOs to say something.
It's an interesting moment. At each Autodesk university, we come with some new connections with industry. For me, industrial design is of great importance. I'll never buy it myself, but this is not for the daily user, but we start with huge transportation means, and we want to affect the entire industry. We want industrial design to be an integral part of any product manufactured by Russian companies. It's a women's team, industrial design. Daria, will you say a few words? Yes, please. Good morning, everyone. Why women's team? It's normal, it's right, it's right. Yes, we make the world more beautiful. Thank you for this important event. For us, it's event. Lab 2050 is the Center of Industrial Design in strategic partnership with Transmash Holding. TNK is the largest in Russia producer of railway transport, one of the largest in the world. Everyone knows our locomotives, our trains, metro trains, maybe electricity-based trains, and it's very nice that such conservative industry as machine building, railway machine building, comes to the conclusion that trains should not be only functional but also nice and beautiful, comfortable for every passenger, to make all you better, all of us better. And it's very nice that Autodesk is going to help us. It's the first industrial design competence center in Russia, the first ever. It's very important. I'm sure we'll be successful. Thank you, thank you, thank you. Daria, Anastasia. Not only women's shoulders will bear the burden, but it will be a center of industrial design where we shall cooperate with many designers, many partners, with the entire ecosystem, with the entire community. At this point, I would like to thank you all who stayed until the very end. I wish you every success, a productive day, an interesting day. Thank you very much.